In one of the previous videos, we talked about containers and what they actually are. Today, I want to talk to you about Docker and how you can use Docker for creating containers. Now, before getting started, a quick introduction to Docker. Docker is simply one of the many tools out there which you can use for creating and managing your containers. Now, apart from Docker, there are a ton of other tools out there as well, but Docker is the most mature one out there and it has the most functionality as well. It will allow you to customize what you can do with your containers. You can customize the behavior, set some custom networking and storage rules, and so on. So within this video, I want to talk to you about the entire architecture of Docker, how it works at a lower level as well, and we look at some hands-on on how you can actually go ahead and use Docker to create your containers. So let us get started. Now, before moving on to the hands-on part, I want to quickly touch upon a little bit of the architecture of Docker. So the main component of Docker is called as the Docker engine. The Docker engine is basically the core of the entire Docker application. The Docker engine is what will take commands in, it will process it and act upon it. Now, before I talk about how you will actually interact with the Docker engine, let's first take a look at the lower levels. So below the Docker engine, you have a component called as containerd. Now, what is containerd exactly? Containerd is like a runtime for actually creating containers. If you worked with JavaScript before, you know that Node.js is a runtime for JavaScript, right? Or simply the V8 engine which runs within the browser. Even that is a runtime for JavaScript. Similarly, containerd is one of the runtimes for running containers. There are other runtimes as well. For example, one popular one out there is called as Rocket. That's one of the usable container runtimes. But containerd is become the standard of container runtimes. Now, if I dive into a little bit of history lesson here, the original containerization tool was Docker. Around 2017, I believe, Docker open sourced its entire source code for what it uses for running and managing containers. Everything that Docker used at a low level, the core of Docker, the core which it used for container management, was put into this project called as containerd. Containerd was created so that it's a lot easier to plug and play containers in different systems. There is Kubernetes, which is something used for managing a ton of containers. So for that, containerd came into existence. Now, don't worry if you don't know Kubernetes, we'll cover it later on this channel. But for now, just know that containerd is basically the core of containerization. Docker uses containerd at its core. Containerd has something called as runc. Runc is sort of a function which actually gives birth and manages your containers. If you look at the source code of containerd, it's using runc at some level. Now, runc is another application which interacts with your hardware, your kernel, and gives it instructions. So the whole process would look something like this. The Docker engine will go and talk to containerd. Containerd then uses this function called as runc to give birth to the containers. Now runc is going to go talk one level deeper and it's going to give the instructions down to your system kernel. All right, cool. Does this make sense so far? Awesome. Now, in order to interact with the Docker engine, there are two main ways. The first one is what we call as Docker Desktop. Now, Docker Desktop is like a front end which will talk to the Docker engine. So it's like an entire GUI interface. You can go ahead and use this, but using this is quite straightforward. So today within the hands-on, we'll be using the other way to interact with the Docker engine, which is the Docker CLI. So you can use either the Docker Desktop to talk with Docker engine, or you can use the Docker CLI to communicate with the Docker engine. Now there is a little bit more to the architecture as well as to what happens when you actually try to run containers. But before we talk about that, let's go and see a little bit of hands-on. Now here I am in one Killer Coda instance of Ubuntu. You can do this locally as well, but just so that everybody has the same sort of environment, I'm doing it over on Killer Coda. Now on Killer Coda, Docker comes pre-installed. If you don't have Docker already installed on your system, simply head over to Google and search for installation of Docker, and you'll get this page of the Docker documentation. So from here, if I select Ubuntu, it's a pretty straightforward process. You can use the install Docker desktop method. This will install the Docker CLI as well as the Docker desktop, and you can get a little bit of exposure to both. Now the process is quite simple. Step 1, you add the repositories of Docker to your list of app repositories. If you don't know what is app repositories, I've made a separate video on how package managers work in Linux. Do check that out to learn how this whole process works. Once you have the repositories initialized within your local app system, just go ahead and install the package and you'll be ready to play around with Docker. Okay, cool. Now, we use Docker for running containers, right? Now, you will have one additional step in your system. On Killer Coda, this step doesn't apply because they use some different sort of system. But if you've installed Docker locally, you are first going to have to go ahead and do something called as Docker login. Now, for this, you just have to create an account on Docker Hub. So simply come over to this website hub.docker.com and create an account over here, and you will use the same account credentials to log into your Docker CLI as well. Even if you use Docker desktop, you are going to have to do this login process. So just keep this one point in your mind when you go ahead and play with Docker. The first thing which I want to show you is how you can actually go ahead and start running containers. So just to make sure that I don't have any container running right now, I'm going to list out every single running container. So for that, I can do Docker container ps. And here it's showing me absolutely nothing over here, which means that I don't have any sort of container running right now. Now there is one more concept called as a Docker image. So let's first go ahead and see if we have any images, and then I'll talk to you about what exactly is an image. So right here you see that I've got 0 images. So now coming back to the point, what is an image? An image is simply a blueprint on how you will build your container. So for example, if I make a custom application and I want to create a container of that custom application, I cannot do it directly. First, I need to create a Docker image, a container image. Using that container image, my Docker or any container runtime will know exactly how to build that image and give me that exact reproduced environment. Now, if you want to understand why we need reproducible environments with containers, check out the videos I did about containerization. If you do want to learn how to build that entire image, I will do a separate video on that later on in the future. But for now, just understand an image is a blueprint for creating a container. Now let's go ahead and run an image. There is a popular web server called as Nginx. That is the image, or rather that is a container which we will be creating. This is a multi-step process. I'm going to do it step by step, and then I will show you what exactly is happening on the backend, what logic is happening. So the first step which I want to do is I want to pull the Nginx image. So I will do a Docker pull Nginx, similar to git pull. What do you do with git pull? You simply pull the source code from an existing repository, right? I'm doing the exact same thing here. So I've pulled this image of Nginx. Let's take a look at it. So I can do a Docker image list, and you can see that I have this Nginx image. The container is still not created, and I know this because if I do a Docker container ps, it doesn't show me any sort of container that's running. Okay, So now I want to go ahead and create a container based off of this Nginx image. So I'm simply going to do docker run nginx, and this is going to create my whole Nginx container. Now over here, it's taken up this entire terminal, this CLI process for running the container. So I'm going to open a separate tab, and over here we can do a docker container ps, and you can see that we have this Nginx container running. I did this in a two-step process. I first pulled the image and then I ran it, right? You can do this in a single step process as well. You can omit the docker pull step and you can directly run docker run and the name of your image. For example, let's take busybox as our image. So it will first check whether the image is available locally or not. If it's not, it will pull it from Docker Hub and then it will run the image. Now, when I run this command, docker run nginx, what exactly is happening? This command, docker run nginx, it gets translated into a way which Docker engine can run, and then from Docker engine, it goes to the lower parts. But what's actually happening? This is what's happening on your local system, right? But what's actually happening is when you run this, Docker is going to go ahead and talk to an external source called as Docker Hub. Now, Docker Hub is simply a container registry, a container repository. How do you have Git repositories where you store source code of different projects? Similarly, you have Docker Hub where you will store container images of different types of containers. Now, apart from Docker Hub, there are other ones as well. So, for example, you have ECR, which is Elastic Container Registry from AWS. You have one from Google as well. You've got something called as Quay.io. All these are different container registries. By default, unless you specify a different container registry, Docker is going to look for the image in Docker Hub. We do a docker run nginx. The command goes to Docker engine, and then Docker engine checks Docker Hub for this image. So how do I know exactly that it's this Nginx image? That's because if you come over to Docker Hub and search for Nginx, the official name of the image is Nginx. This is the name of the image. And then we have all these tags as well. These are different versions of Nginx's image. And if you check the overview tab and check out all this supported, you'll see that we have all these different variations of the Nginx image. And then you have all the reference as well, which you can check out. Now, if you want to look at every single image that exists in Docker Hub, you can check out the search images tab. Over here, you can see absolutely every single image that exists on Docker Hub. Assuming that it's a public image, of course. You have private images as well, but obviously those are private, so you cannot actually see them, not in this public registries. Let's say that your Docker engine finds the Nginx image in Docker Hub. Then it's going to pull it from there, right? So Docker Hub will send back the correct information, and now you have the Nginx image on your local system. Now, in case the Docker engine wasn't able to find the correct image in the Docker Hub, it will throw you an error that such and such image is not found. Let me show you that as well. So let me purposefully make a typo in my image name. So I can do docker run nginx with two x's. Now here you can see that the whole process failed because I gave it a typo. It's saying pull access denied for nginx with a typo. That's because it's trying to check for it in a private repository. But since I'm not logged in over here, Docker login is required, so it cannot access that private repository. But of course, even if I was logged in, this wouldn't work because Nginx, the typo version, doesn't exist on Docker Hub. So it's going to fail this entire process. So yes, that's how the whole process of Docker works. We looked at the architecture of Docker, we looked at the components which it uses, we also saw the entire process behind it, and we saw a little bit of hands-on as well. I'm going to make more videos on Docker as well about how to do different things within it. So stay tuned for those as well. Hope you had fun with this video, and feel free to go ahead and try out Docker and play around with it.